Hi there! This video series is to display my problem-solving and learning abilities. I plan to show that I can solve any programming problem, regardless of whether I already have expertise in a particular language. I hope this helps others in my field to learn not just how to solve a particular problem, but how to teach themselves a solution to an unfamiliar problem. Currently, I am learning Python. I have no professional experience in the language and have only been learning it since mid-January. My only formal training is completing the Python for Programmers course on Execute Program. While I'm picking Python up fairly quickly, I cannot claim any real expertise. Today, I'm showing my approach to solving the 27th Project Euler problem from start to finish, vocalizing my thought process throughout. As always, I will link to Project Euler and my repository in the description. Let's dive in. Problem 27 is quadratic primes. Euler discovered the remarkable quadratic formula n squared plus n plus 41. It turns out that the formula will produce 40 primes for the consecutive integer values 0 less than or equal to n less than or equal to 39. However, when n equals 40, 40 squared plus 40 plus 41 equals 40 times 40 plus 1 plus 41 is divisible by 41, and certainly when n equals 41, 41 squared plus 41 plus 41 is clearly divisible by 41. The incredible formula n squared minus 79n plus 1601 was discovered, which produces 80 primes for the consecutive values 0 less than or equal to n less than or equal to 79. The product of the coefficients, negative 79 and 1601, is negative, 126,479. Considering quadratics of the form n squared plus an plus b, where the absolute value of a is less than 1,000 and the absolute value of b is less than or equal to 1,000, where n is the modulus slash absolute value of n. For example, the absolute value of 11 equals 11 and the absolute value of negative 4 equals 4. Find the product of the coefficients a and b for the quadratic expression that produces the maximum number of primes for consecutive values of n, starting with n equals 0. Okay, so obviously this is going to be another thing where we need to go back and get our isPrime function. I feel like it's been quite some time since we used that, so we might have to dig through our old code a little bit, or I'm sure it's Visual Studio Code. They have to have a search all files feature. So let's start by getting this like plain text version. And then go to our Visual Studio Code. And do our little whoops. That's a new feature. Okay, so find the product of the coefficients a and b for the quadratic expression that produces the maximum number of primes of consecutive values of n, starting with n equals 0. Okay, so first things first, as usual, we're going to go ahead and do Yoink. Okay, so next we're gonna go ahead and find our search files by name. So that doesn't actually help. Let's see. So I am now trying to remember, when did we last do anything with primes? And let's see. So we definitely need this. This is factor function. So we'll pull that over. What was that? 10. There's our is prime. Okay, so this is my particular, I guess, way of doing things, where I don't really want to redo work that I have already done, if possible. So just making sure that we have the things that we've already created here. Actually, I'm going to go ahead and move this up to the top now. Okay, so we have our is prime, we have our is factor, which is necessary to run is prime. We may have done something else with primes more recently, but I think this is a good enough formula for this. So we basically want to have, and let's go ahead and set up a limit of 1,000. And I'm more or less thinking that we might want to brute force this. So let's see. So maximum primes is equal to 0. Because what we're going to end up having to do in order to do this without knowing more high-level maths is simply make the formulas and test them out, right? So what's a great way of doing this? So we have to have our maximum primes, and then along with that, we're going to have our max AB, and I'm going to have that be 0, 0 for now. And then what I am going to do is basically a triple for loop. Now that's not going to be very efficient, but we're testing few enough values that I'm hoping it might work. So let's see, absolute value of A less than 1,000. So for A in range, -1 times -1, and we want to go up to, but not including the limit. And for b in range limit times -1, and then limit +1. Obviously, this is going to be a heck of a lot, right? So, it's going to be interesting. And then we want for n in range. I'm guessing that none of these are actually going to be able to be over 1,000. But let's see. So for n in range 0, which is the default, so we don't have to type it, and let's do limit times limit, just to cover all of our bases. I don't think we're ever going to get that high. And then actually, let's create a little def for def. Let's see. Find prime. Or, what is it? Find answer. And we're going to take an A, a B, and an N. And this is going to be n times n plus a times n plus b. Which I suppose now that I see that that's a one-liner, maybe we don't need that. But let's go ahead and do this. So for n in range blah blah blah, if is prime, find answer a b n, then count e plus equals 1, else break. Now, I'm not 100% sure if this will only break us out of the end loop, but I think it will, because it should work that way. Okay, and then there's a couple other lines we need here. If count is greater than max num primes, max num primes equals count, and max AB equals AB, which I believe should allow us to do and let's go ahead and set our limit to 100 first, just to see how long that takes. But hopefully that'll be an answer. Oh, and we haven't actually run this yet, so problem 27.py. Okay, so we got 9,801. I am not satisfied with that because I am kind of curious. How many primes did we find? Okay. Product of the coefficients that produce the maximum number of primes. Interesting. So if we go back to our 1000, which is the actual question, it'll probably take a lot longer to run. Let's find out. Because and 33 is good because that's a lot smaller of a number than like even the 100. And unfortunately, this is, again, taking quite a while. Okay, so I'm not sure. Should we just leave that running? I think for right now, let's just leave it running while we think about how do we make this more, how do we make this a little bit more, goodness. Wait a minute. A equals negative 99 and B equals negative 99. N equals 0 would be negative 99. Right? Let's look again at our formula. So n squared, so if n equals 0, n squared would be 0 plus a times n, also 0 plus b. Negative 99 is not a prime number. Our is prime method is wrong. Okay. Just gonna real quick do a little Google for Visual Studio Code. Find in files. Control-Shift-F. Okay, so we went from problem 7, and it's the same as in problem 5, which is the same as in problem 3. And the problem with this method for problem 27 is we're not necessarily going through in order, so we can't just do for I and primes and check whether those are factors. We could build out our primes list a little bit more, but I think a better strategy is going to be just change how we calculate whether something is prime. So here's what I'm thinking. Instead of doing for I and primes, we want to do basically from 2 through whatever. So for I in range 2, I know there's a square root function in here somewhere. That's right. It was just 0.5, I think. And then we want to make it an integer. Okay, so now it's going to be start with the number 2 and go through to the square root. And I'm actually going to make that plus 2, just in case. And if any of those numbers are a factor of the possible prime, then we return false. Otherwise, we append it to our primes array and return true. And that's going to make us more correct anyway, probably a tiny bit more efficient. And we're also going to go ahead and say, okay, so it did finish. It took 7 minutes, but it finished. Found 88 primes for this, which is 6177. I'm going to leave that there. I am highly confident that that is the correct answer, but I don't want to check it yet. I want to make sure we're beating that under a minute limit first. And one thing that I am going to do that is say if not is prime b, continue. So skip to the next value of b if b is not prime. And let's see how much that helps. Okay. Int argument must be a string, not complex. I am a little confused right now. so we need to figure out the absolute value of b, not... Because if you take the square root of a negative number, it's like times I and something. I wonder... Our negative numbers prime. No negative prime numbers. So, instead of driving ourselves nuts trying to find all of the absolute values and stuff, so b has to be positive because b itself must be a prime. So that's going to cut us out quite a lot. And then here, we're just going to change is prime. And we're going to say if possible prime is less than... Is 1 a prime number? No. So, if possible prime is less than 2, return false. Okay, so that should cut us out significantly and prevent seeing this error again. Like, it should cut down a significant amount of our processing time. Okay, so 71 primes for a equals negative 61 and b equals 971. A times b is this negative 59231, and we processed in 7 seconds, which is well under our minute mark. Let's check this answer. This answer, very different from our previous answer of, like, finding 88 for b equals negative 71. A negative 71, not a prime number. So, is clearly wrong for 0. So, let's see, we've got our 59,231, that is negative. Is this the correct answer? And it is! Alright, so... What did we learn? There are no prime numbers less than 2. Actually, I'm gonna Google for 0 as well. Okay, so there are no prime numbers that are less than 2. So A can be negative, B technically cannot. That was a bit of a red herring in the problem statement. So yeah, so really all we did is we modified our isPrime formula to handle use cases where, like, we hadn't already tested that number, or we hadn't already tested all of the numbers lower than that one. And we went through all of the possible values of A. For every possible value of A, we went through all these B values from 2, which is the smallest it can actually be. And I did just make that change. We'll see if it runs any faster. To the limit, so inclusive. That's what that +1 does. If B is not a prime number, we just skip to the next B. If it is, then we start our count at 0. And for n in range limit times limit, making sure that we're going as high as possible, we check whether the answer that we find is a prime number. And if it is, we increase our count. If it isn't, we break out of this for loop, check our count whether they're against our max, and do the normal max checking things, and then print out our answers. So, I think pretty clear formula here. We do have a third nested for loop, which is not ideal for efficiency. I bet if we upped this to 10,000, it would take way too long to run. But still, it's currently running in 7 seconds. Should take a tiny bit less time now, since we started B at 2 instead of 0. Yeah, same answer. No, about the same amount of time. So yeah, I'm gonna call it there for this one, and I'll catch you in the next.